Okay, everyone, welcome back to SAT Math. This time it'll be week 2, part 1 of the lecture. Jumping right in, we are working with linear functions today. So we'll be starting off with new questions that we haven't done from the previous session. This time we'll be looking at depicting depreciated value. So if you look here, we have a market value of a piece of construction equipment, and we can see that it was originally constructed in 2010, and the market value decreases as the years go on. And we have to figure out which function matches the market value v when it is t years old. Okay, so when we first do that is we have to look at what we're given, and we can figure out the slope. So using the initial points, we'll use 2012 as 2 and 2015 as 5 because we're working with 2010 as the original year. So we'll end up getting negative 7,250. And it is easier to work in point slope form this time, simply because we have two initial points, but we don't know what y equals, and we don't know the y-intercept. So it's easier just to work in point slope form and figure it out from there. So we'll convert this to our v and t instead of y and x, and then we'll get v minus 87,250, and we'll just plug in x1 as 2 from 2012, our initial points, and we'll just solve it out, and you'll end up with v of t equals negative 7,250 t plus 101,750. Okay, predicting car sales. A car dealer finds that as she increases the asking price for a certain model of car, the number of cars she sells decreases linearly, meaning every $1,000 increase in price, she loses 5 customers. So if she lists the asking price at $20,000, she sells 5 cars. Okay, so figuring this out, we have to figure out which is our independent variable and which is our dependent variable. So in this case, price is our independent variable, and the number of cars sold is dependent on the price. And we do know that for every $1,000 the price increases, our car dealer loses 5 customers. So that's a negative slope. And the only option choice with this negative slope is option C. Okay, charging a phone. Stella's phone had 43% remaining battery life before she plugged it into charge. At 5 minutes, she now has 53%. 5 minutes later, she has 63%. So this might be a little bit confusing at first, but we just have to look at what we're given. We're looking for t in minutes. We started with 43%, and after 5 minutes, we had a 10% increase. And after 5 more minutes, again, we had a 5% increase. So we have a linear function here that increases 2% every 1 minute, meaning it has a slope of 2. And considering we started at 43%, f of t equals 43 plus 2t. Okay, discount price. A company produces baseballs, $5 each. To encourage large orders, they have a discount on orders between 100 and 300 baseballs. The discount is 1 cent for each baseball above 100. And which function represents price P of each baseball B receiving this discount? Okay, so we have our options of slopes as 5 or negative 0.01, and that is what we have to figure out first. So you can convert this into y equals mx plus b. And y will be p of b in this case because p is our independent variable, or the x-axis, and p is our y value, b is our independent variable, x-axis, because the price is dependent on how many baseballs you order. So we're looking at the minimum order must be 100 And to get the discount is you have to buy 101, at least 101 baseballs. So we're looking at the price of 5 baseballs each, and we're trying to figure out how much discount per baseball. And to do that, you have to do 5 minus 0.01 times b minus 100. And that minus 100 is from the 101 baseballs you have to order in order to get that cent discount. Now, once you simplify this, we have 5 minus 0.01b plus 1, or, 0.01b plus 6. And that comes from, again, how many baseballs you order above 100 baseballs, you'll receive a cent discount. And the more baseballs you order, the more discount you'll get, which is represented by our graph here. Okay, the bakery's oven. We have this, estimation formula. T of x equals 36 plus 2x. X is the number of cookies, meaning t, the y value is time. How many hours will it take to bake 6 dozen cookies? Now keep in mind, t is in minutes, but they want it in hours. So that's something you have to be careful of. Okay, I'm assuming you guys know 6 dozen is 6 times 12. A dozen is 12. So we just have to plug in how many cookies we have into our equation. T of 72. Just solve it out, and you end up with 180 minutes. But that's not the tricky part. Remember, you have to turn it back into hours. So please don't get this wrong. Please keep in mind units. I wrote it mathematically, but I'm sure you guys know there's 60 minutes in 1 hour. So it will take 3 hours to bake 6 dozen cookies. Okay, given the function, find the output. This just means you plug in b, and you plug in x, and we find y. Or sorry, not y. We find a. So what you'll do, you'll start off your function. You plug in x as negative 1/4, and you plug in b as 1/2. Pretty straightforward. Kind of just solve it out mathematically. You end up with 2a minus 1/2 a, and you'll get 3 over 2a, or 1.5a. Okay, Angelica's voice classes. Due to successful social media advertising, enrollment in Angela's voice classes are increasing. So we see an increase each month, and it's a linear progression with 20 plus 2w. What is that 2? So nothing too crazy for this question. We're increasing 8 students a month, but we're looking at w in weeks. So we'll just convert that slope into per week instead of per month. You'll get 2 students a week, meaning the correct answer for that 2 is the rate of change in the number of students per week. Okay, Eliza's books. This one is pretty straightforward. She reads digital books on her phone. She downloaded 3 books and plans to download a constant number of new books each week. So we just have to test all these conditions. But just checking what we're given. When after 4 weeks, Eliza will have 11 books. So that means after 1 month, Eliza will have 11 books. So this one, just interpreting the graph in terms of the question, not too difficult. You just have to be able to remember to read your options very carefully. So A will say 4 books after 11 weeks. That doesn't exactly fit our graph. 11 books after 4 months. Again, that's pretty high, and we don't actually, we can't actually see the graph for 4 months, so just keep that in mind. D says 11 months, and that will just be wrong. So our correct answer here is C. Okay, mountain biker's attitude. They're at an elevation of 1,000 feet. He cycles at a constant speed of 5 miles per hour Its elevation is a steady 100 feet per mile. And then we have our linear function. Which graph matches this best? So first, we actually just have to solve for it with what we're given. He's at 5 miles per hour, and he's gaining elevation at 100 feet per mile. So we can figure out that slope based on what we're given here, and we'll end up with 500 feet per hour. And because we started at 1,000 feet high, that'll be our y-intercept. So the correct answer choice from our options is D, because if you look at this graph here, you'll see we have a y-intercept of 1,000, and we do have a slope of 500 as well, meaning after 2 hours, our mountain biker will have climbed 1,000 feet, and we see that after 2 hours, there's a total elevation of 2,000 feet. Okay, this is our final question. Cost of cookies. A bakery is hoping to increase sales by introducing a new loyalty program. They buy a loyalty card for $10. The customer is entitled for discount $1.50 per cookie. And the first half dozen cookies are free. So again, we just have to mathematically solve it with what we have. Just set up the formula in y equals mx plus b form. So we do know that 10 is the cost of a card, just a flat fee, and each cookie is discounted $1.50. And again, half dozen is 6 cookies. You guys should know this. So setting this up in terms of c of x, we have c of x equals 10 plus 150 times x minus 6. And that minus 6 comes from the first 6 cookies being free. You get 6 cookies, you don't have to pay anything extra. Okay. And remember, we have to just plug in certain numbers to, fit our option choices. So if you do c of 6, just be 10. C of 5 will still be 10. C of 4 will still be 10. So we have to go a little bit higher than 6 to find out what we're looking for. C of 10 equals 10 plus 1.5 times 10 minus 6. In the parentheses, you'll end up with 16. C of 16, you'll end up with 25, and you'll see that it matches our answer choice C from the number of cookies to cost labeled in the table. Okay, so that'll be our last question for today. And if you guys like this video, please like and subscribe.